All right, today we're going to talk about the law of cosines, and I want to talk a little bit about the formula. So previously in 13.5, we looked at the law of sines. The law of cosines is just another relationship in any triangle. And I want you to understand that this little formula has variables in it, but I want you to not get caught up on the letters themselves, but it's more about the connections between what the letters mean in the triangle. Okay? So for any triangle ABC, remember the vertices are capital letters, the side lengths are lowercase letters, and then opposites are always the same letter. Opposite angle C is side C. All right, so if you look at the formula, basically what it says is if you take a side squared, it will be equal to the second side squared plus the third side squared minus 2 times the second side times the third side times the cosine of the angle that is opposite of this side that you put here, okay? That is what is most important to understand about that formula. So this will be one side, this will be the other two sides. This will be those other two sides. And then this will be the angle that's opposite of the side here that starts off the formula. Alrighty? So over here I'm going to circle those in pink because those are important. So basically what happens is you either are going to be asked to find a missing side, knowing the other two sides in this opposite angle, and then you just plug in the information, so the other two sides, and then the angle opposite. Solve that out for the side, C, or whatever it's labeled. Or you may be given the side here that's opposite and the angle's missing, but you're given the other two sides. So then what happens is you put in all three sides, but this side has to be opposite this angle that you're trying to find. And then the A and the B will be the other two sides. So it's important that you understand that relationship. Okay? So now we're going to talk about law of cosines day 1. And for the most part, we're just going to do it one direction, and then tomorrow or in the next lesson, we'll talk about solving for the angle versus the side. So, you know, the previous lesson we did 13.5, which is law of cosine. So another skill that you're going to have to master here is eventually, given a triangle, you have to decide which law to use. And usually there's only one law that you can begin with. The good thing is if you pick the wrong law, you actually get stuck. You cannot solve. So therefore you would be forced to use the other law. The goal would be to try to pick the right law first because that would save you time. Okay? All right, so here we go. Again, here's our relationship. That's our formula. And the side here that we plug in here has to be opposite the angle here that we plug in. Now, we will not know one of these, and we will know its opposite. Okay? Vice versa, we'll know the angle. Not the side, we'll know this side, and not this angle. Okay, so again, I'm gonna circle this because this is super important no matter what your triangle is labeled. So example number 1, solve triangle WXY, which means find missing pieces. We are given that side W is 8, side Y is 10, and angle X is 48 degrees. So the first thing we're gonna do is we're gonna draw a triangle. And again, I just have a go-to triangle shape. I'm not really concerned about acute angles, obtuse. I'm concerned about the relationship. So I'm just going to call it a triangle W, X, and Y. Super important that you label. Now, this says that little w is 8, so cross from angle W is side 8. And then this says that side Y is 10, so across from angle Y, we have side 10. And then we're given that this angle X is 48 degrees. So what this is called, if you remember in geometry, is we are given side, included angle, side. So it's called side angle side. And basically if you have side angle side information, you would always use the law of cosine first. And the only thing we can find first right now is this little side here, little x. if we tried to set up the law of sine right now, we would not have enough information. We would not have enough. So these two here are the pieces that have to go here. So we're going to put an x in for this little c, and then we're going to put a 48 in for the big C, which is the angle. Okay? So it looks like this. We have x squared equals, then we just grab one of the sides. I'm just going to grab 10 squared plus 8 squared minus 2 times 10 times 8 times the cosine of angle opposite of this little side here, which is 48. Okay? Now what I want you to notice is look at this right side of the equation. There are no variables here, none whatsoever, which actually means that we can go to our calculator right now and we can literally type in exactly what we see without stopping. All right, so here we go. I'm going to move this up a little bit. So we're going to go 10 squared plus 8 squared minus 2 times 10 times 8 times cosine of 48. Close that parenthesis, enter, and you get 56.939. All right, now if you go back to your equation though, that's equivalent to x squared. 56 point, I'm going to round to the nearest hundredth, 94. So before we're done here, we got to get a 1x to the first power by itself here. So we're going to go to our calculator and we're going to go second square root and then that last answer. So we get 7.55 is x. I'm rounding again to the nearest hundredth. And that is our first missing piece. Okay, and it is the only piece that we can actually find. So I'm actually going to grab my pencil and I'm going to plug that value in right down here, so 7.55. So what's going to happen next is I could use the law of cosine again to solve for either angle W or angle Y, but I can also move into the law of sine, which of course the law of sine is a little bit faster. So we're going to go ahead and move into the law of sines. So I'm either going to pick angle W or angle Y. It does not really matter. I think I would just get in the habit of always finding the angle that's opposite the biggest side first whenever possible, and we'll talk about that later, but that'll just keep you safe for a future. So we're going to use the concept then, the law of sine, so we have the 10 and the opposite angle is unknown, but we do now have this pair, which we know both, the angle and its opposite side. So here we go, law of sines, we're going to go sine of 48 over 7.55, and I hope I got that right, because if this is wrong from our previous work, then this is going to be wrong here. So then sine of y all over 10, and remember this is where we cross multiply. So we're going to times this side over here by 10, the 7.55 over here, and so it looks like this, 10 times the sine of 48 equals 7.55 times the sine of y. We want to get the sine of y by itself right now, so we're going to divide by the multiplier, 7.55 over here, divide that by 7.55. So again, move this up a little bit. I'm going to get my calculator out and clear that. And we're doing 10 sine 48, close that, divided by 7.55, and enter, and we get 0.9843. Remember, we're going to go at least 4 decimal places here. 0.9843 is this side, 0.9843 is equal to, these cancel, so we're left with the sine of angle y, and then undo a sine. We do an inverse sine of 0.9843. So second sine 0.9843. Again, you could just grab that previous answer, but as long as you go 4 decimal places, you should be safe. So that means that angle y here, because this cancels out, so we're left with y equals 79.83 degrees. All right, so there's our second piece of information. And I'm going to go back to my triangle again, and I'm going to plug in 79.83. And I find that sometimes you guys want to do the problems so fast that you don't want to take the time to go back up here and put in the pieces that you know. But seriously, if you just take a little more time on math, things start to make more sense, and you get better at detail. You just kind of become a better problem solver. So now, thinking about this scenario, we have 2 of the angles out of the 3. The easiest thing to do now would be to do the triangle sum theorem. Anytime you have two angles in your triangle, the 3 angles have to add up to be 180. So it's the fastest thing to do. So here's our last piece that we need to work out here, is that angle W plus 48 plus 79.83 has to add up to be 180. So I'm just going to grab my calculator here. I'm not going to show a ton of work because we do have a lot to do. So we kind of want to streamline a little bit. So I'm going to take 180 minus 48 minus 79.83. Enter that, and I get that angle W is 52.17 degrees. Now, I'm hoping that along the way I didn't make any mistakes. Of course, if I did, you will let me know, please. So that is a very basic problem for the law of cosines from day 1. So the next thing we're going to actually look at, just for time, I want the video to be pretty quick. Number 2 is basically the same, but let's look at number 3, which is the word problem. And take a second, let's read it together. A surveyor is measuring a lot for a land developer. The triangular shaped lot is bordered by 2 streets. The 2 streets intersect at an angle of 110 degrees. Call this intersection point A. The distance from A to corner 2 is 175 feet. The distance from A to corner 3 is 142 feet. Due to a pond that runs through the back of the lot, the surveyor is unable to directly measure the third side. Trigonometry to the rescue. We are to find the third side. So we are going to draw a picture. We basically have a triangular shaped lot. Again, just get it in there. But one of the angles is 110 here. So let me highlight that super quick. One of the angles is 110. So I'm going to try to draw my picture with an obtuse angle, obviously. So I'm just going to go like this. Make that obtuse. Approximately 110. Doesn't really matter. We're supposed to call that point A. So I'm going to go ahead and, there we go. Put in the 110. Then it says that the 2 streets border this and intersect at a 110 degree angle. So that's the street. Here's one of the streets, sorry, and this is the other street. It says that the distance from A to corner 2 is 175. It doesn't really matter which side. I just want to put in a 175 there. And then the distance from A to corner 3 would be 142. So I want to put in, oops, I almost wrote that wrong, a 142 there. And the question is, what is the length of the third side right here? Because there's a big old pond going through here, and we can't measure it. So, there's your pond. All right, so it is a law of cosines because we are given information that is side angle side. But if you don't remember that, again, if you try the wrong formula, it just doesn't work. So the law of cosines here, I'm gonna circle these 2 because these 2, remember, have to be these opposite 2 pieces. So the 110 is this right here, and then the variable x is right there. And then those other 2 sides, they just fill in the other stuff. So with a little practice, you guys, this formula is not very difficult. But it does take time to understand the relationship. So here we go. So we've got x squared equals 175 squared plus 142 squared minus 2 times 175 times 142 times the cosine of 110. And again, you're just going to type that whole thing in your calculator. Order of operations, though, if you're not going to do it in one whole swoop, you can put these two together. And then you can multiply these together. And then you would subtract very, very last between these and that portion, because this is all multiplication. And that has to be done before addition, subtraction. So anyways, here's my calculator. Super quick, clear it out. And 175 squared plus 142 squared minus 2 times 175 times 142 times cosine 110. Close it out. Just get in the habit of closing that out because it's good to do. So what we have here is that x squared is, let's see, 67787.40. So 67,787.4. And so the next thing we have to do is square root both sides. So I'm going to go second square root, second answer down here, so it takes that whole thing. And I get that the missing side is x equals 260. Let's see, it doesn't say where to round, so let's round to the nearest hundredth. It is a word problem. We need to label feet. And there's your answer. And that is one of the reasons trigonometry is actually very applicable, is because you can find measurements indirectly instead of measuring straight across. You can actually use other information. So that's a word problem. Remember, please don't skip word problems. They are super important for your problem solving, development, and your resilience, just not giving up. All right. So the last thing I want to talk about in the law of cosines, day one notes, is an area formula. So law of sine, or sines had an area formula, and cosine doesn't really have a cosine formula, but it has to do with when you know all three sides of a triangle, you can find the area of it. And the connection to the law of cosine is, if you have all three sides of a triangle, you would always use the law of cosine to find the first missing angle. And we actually do that part of cosine tomorrow. So I'm going to wrap up the notes here by just doing one of these examples. I'm going to actually do this one because the numbers are just a little bit bigger. But I want to talk about the formula super quick. So this is called Heron's area formula. The area of any triangle, if you can find the semi-perimeter, so the S is the semi-perimeter, which semi-perimeter just means perimeter cut in half. So you add the three sides, divide by 2. You have the semi-perimeter. Then in the formula, what you do is it's the square root of a product of some special pieces. You put the semi-perimeter here. Then you take the semi-perimeter minus one of the given sides, and that goes there. Semi-perimeter minus a second side goes there. Semi-perimeter minus the third side goes there. You multiply those four numbers together. You take the square root, and you actually have the area of the triangle. Okay? So this would be the third formula you have then for area of a triangle. You have the one in geometry, 1/2 base times height. You have the one from the law of sines, and then you have this one in section 13.6. So first thing I'm going to do then, if I look at number 4, I am going to, I don't really need to draw a triangle, but I think I will just for the sake of having it. So basically you have this triangle, and the three sides are 21, 17, and 29. And the formula up here is to first find the semi-perimeter so you can use it. So the semi-perimeter is simply taking 21 plus 17 plus 29 and then dividing that by 2. I'm going to try to do this without a calculator. So here's 20, 40, and 1 and 9 make 10, so 50, and then 17 more would be 67. Divide that by 2. I'm going to just do it, I know I could do that in my head. So 33.5 is the semi-perimeter here. Okay. So then what I do is I go to the formula. So for the area of the triangle, I'm going to take the square root, which is the last thing I do, but I'm going to take the 33.5. That goes here. Then I take one of the sides, 21, or time out, you guys. I take the semi-perimeter minus one of the sides. Then I take the semi-perimeter minus a second side. Then I take the semi-perimeter minus the third side. Close it. So each of these differences I need to find separately and then times it all by the semi-perimeter. All right, so grabbing my calculator, I'm going to clear that out. And again, I'm not going to do the square root part on my calculator, but I'm going to do 33.5, and then I'm going to put a parenthesis. And I'm going to just do this. Close that, open a new one. Close that one, open a new one. And now what I have is that product under here. So the area of the triangle right now where I'm at is the square root of 3109.2.19. I'm going to go ahead and round. And then I'm going to take the square root of my previous answer, and I get that the area is 176.33. And it did not give me a unit of measure, but it is area, so I'm going to do units squared. So we have square units, and that is the formula then that you're going to be using in your homework today. You do not need to memorize the formula. You do need to understand that S means the semi-perimeter, but this is usually given as well. So that then concludes our law of cosines day 1. And just want to leave you with a little quote like I like to do. And here it is. Integrity is doing the right thing when nobody's watching, right? So keep that in mind.